All right, let's do some more of the Z-score problems. So this is still 12.5, but these are in context, okay? So let's see if we can get these set up. So here we have a company that's installing light bulbs, and these light bulbs have been determined to have an average life of 500 hours with a standard deviation of 100 hours. So we know this is your X bar, right? I can't write there. That's your mean or your X bar, and the standard deviation of 100, that's your S. Okay. And we're told the distribution of the lengths of life of these light bulbs is approximated by a normal curve. All right, our job is to get the percentage of bulbs that can be expected to last the given period of time. Okay. So I always like to draw it. So I'm told that the length of life is approximately normal. So I can draw my normal curve. Here would be the mean, and then here's 1, 2, 3 above, 1, 2, 3 below. All right, 500 would be right there in the middle, okay? And 460 is then below the mean, isn't it? I'm told the standard deviation is 100 hours. So this would be 600, 700, 800 going above, and then 432 going below. 460 would be a little closer to the mean, would be like right here, a little closer than halfway between 0 and 1. Okay. All right. So what I'm going to do is find the Z-score that corresponds to 460 hours. Even though it says less than here, less than or no more than, you wind up using the 460. There's a lot of data values. You don't worry about 459 versus 460. Use the 460. So you would do the Z-score corresponding to 460, and you would do that by taking 460 minus the mean, dividing by the standard deviation. So that's negative 40 over 100, which is a negative 0.40. Okay. Then you go look up the A that corresponds to that, and you find the A corresponding to 0.40 is 0.155. It doesn't matter that it's negative because of the symmetry. You know, either way, it's going to give you this. Let me see if I can change colors here. It's going to give you this from the mean to that Z-score. This would give you the percentage for that. So that's in percent, that would be 15.5%. Okay. But you have to be careful. That 15.5% represents this. From the Z-score to the mean is 15.5. But they want to know less than that amount. So remember, this spot right here is the 460, right? So what we're supposed to find, let me do it with red, is actually from that value down here. So here was the mean, okay? We know the blue is 15.5%. Should have had a percent sign on that. But we want to know the rest of it on that side. So we should take 50% minus the 15.5%. And when we do that, that would give us 34.5%. So you have to draw a picture because it's not always going to be just a directly, like it's not 15.5. That is what you see shaded in blue. We want the red part that I have lines on. So we want this part right here. So that would be 50% minus that 15.5. Your answer should be 34.5%. Okay. All right, let's think about 19. On 19, normally distributed, there's the mean, there's 1, 2, 3 above, 1, 2, 3 below. All right, this one wants us to find the percentage of the bulbs that could be expected to last at least 500 hours. Well, the mean is 500 hours, isn't it? At least 500 means 500 on up. So that would be that. And can you see from that graph that that would be 50%? 50% of the bulbs should last more than the average. So that one I didn't really have to calculate. Okay. All right, now the next two are a little different. If that same company, the one from above, if we know the number of light bulbs, rather than just putting the percentage we would expect, we could actually give the number of light bulbs we would expect, okay, to last the indicated amounts of time. All right, so on this one, I want between 540 and 780. So let me draw a picture. Let me think about where those are. The mean is 500. 1, 2, 3 above. 100 was the standard deviation. So the first one standard deviation above the mean is 600, then 700, then 800. So let me change colors. And in green, I'll show the two we're looking for. 540 would be a little less than, didn't change. Let me change it again. Oh yeah, it did. Okay. A little less than halfway to 600. 780 would be closer to 800. Okay. Over there. And I want to know how many light bulbs I could expect to last between that many hours. Okay. Between 540 and then over here, 780 hours. So I need the z-score for each of those. So the z-score for 540 can be found by taking 540 minus 500 over 100. That turns out to be 0.40 positive. The z-score for 780 equals 780 minus 500 over 100, which is 280 over 100, which equals 2.8. Okay. The A value for each of those, the A value for 0.40 was 0.155. The A value for a z-score of 2.8 turned out to be 0.497. Now you can keep it a decimal since you're going to need to be multiplying by 5,000 to get the actual number. If you want, I usually, in my mind, think 15.5%, and here I have 49.7%, and both of those represent from the z-score. So 49.7 is from here to the mean, and then 15.5 is from there to the mean, and I want in between those two. That's going to be a subtraction problem. See how those two values are both to the right of the mean? They're on the same side of the average value. I'll be subtracting. I'm going to be taking 49.7, subtract 15.5, and that gives me 34.2. So I know 34.2% of the light bulbs should last between those numbers of hours. Then I'm going to take 34.2% of the 5,000. So change it to a decimal. It would be 0.342 multiplied by 5,000, and that gives you 1,710 light bulbs. 1,710 light bulbs. Okay. Now you could have kept them as decimals and taken 0.497 minus 0.155, and you would have gotten the 0.342, and then multiplied by 5,000 because they asked us the number of bulbs, not the percentage of bulbs like they did here. Percentage of bulbs, you just need to give me what percent you expect to fall there. Right? And then this last one was number of bulbs lasting more than 400 hours. So let's think about that. Average was 5, 1, 2, 3 below, 1, 2, 3 above. So we're talking about more than one standard deviation below the mean. Okay, so we're supposed to give this right here. Okay, so first I need the z-score corresponding to 400. I do that by taking 400 minus 500 divided by 100. So that's negative 100 over 100, or negative 1. I'm right at one standard deviation below the mean. The A that corresponds to that z-score turns out to be I didn't write it down, but I think it's 0.341. Okay, which is the same as 34.1%. Now it represents, let me change it to blue, 34.1% represents just this piece, right? Just the part from from the 400 value to the mean of 500. How many light bulbs, or the percentage of light bulbs that would be between those two. But notice I want all the way from 400 on up, more than 400 on up. So I will think about how this piece right here is 50%, right? Half of it. So I'm going to take 50% plus 34.1%, and that's going to give me my answer on this, 84.1%. Okay. Oops, that's not my answer. Sorry. It wasn't asking for percent. That gives me 84.1%. And then finally, I need to take 0.841 times the number of light bulbs. And that gives me the answer. That's 4,205 light bulbs could be expected to last more than 400 hours. Okay. We know 2,500 of them last more than 500 hours. Okay. And then we've got an additional quantity that we get to add to that. Okay. So half of them last more than 500. And then this is a big chunk right here. Okay. Remember how from one below and one above, that would be about 68%. Okay. So, yep, 34.1% would be the percentage of bulbs we'd expect to last from 400 to 500. So add the 50 to that and then calculate the number of bulbs and you get your 4205. Okay. All right. One more problem dealt with the lengths of human pregnancies. Oops, got an extra L there. So we're assuming they're normally distributed. It says the mean length of a human pregnancy is 268 days, standard deviation of 9. So like 1, 2, 3 above, 1, 2, 3 below. So for instance, standard deviation of 9 days, if I added 9, I'd get to the 1 standard deviation mark. 9 plus that would be 277. Okay. All right. I really don't have to label everything. I noticed they're asking me questions about what percentage of human pregnancies do we expect to last no more than 272 days? So that would be 272 would be somewhere in here. Okay. And so what I'm going to do is figure this out because that's what I can get out of the Z-score table. But I need not just that, I need last no more than. So they can't go beyond 272, but they can be below. So I really need all of this from all the way down here, all the way to 272 days. So I need a Z-score for 272. So I take 272, subtract 268, divide by the number, the standard deviation number. So the deviation from the mean would be 272 minus 268. So that would be 4 over 9, which would be 0.44. Keeps going, but the table uses 2 decimal places. The A that corresponds to that 0.44 is 0.17, okay, which is 17%. And that tells me this little piece right here. From the mean to 272 would be 17%. But then we have the other 50%. So we have to take the 50% plus the 17, 50% being this region here, right? And that would give us 67% of human pregnancies would last no more than 272 days. So that's part A. I didn't give you 2 blanks, but that would be part A. And then they want in part B, if we had a sample of 200 pregnant women, how many could we expect to have pregnancies that last no more than that? So for the part B, I'm going to take 67% of 200. 0.67 times 200, and that turns out to be 134. So that would be the second part, 134 women, pregnant women. We would expect to have pregnancies that last no more than 272 days. Okay? All right, I hope this helps.